afternoon, students. Today we discuss some important questions, some important Neet or JW questions on the chapter oscillation. So the oscillation is also the important chapter for the Neet exam or CT exam. So here we discuss some questions for this chapter. Yes, here the first question: a particle of mass m, a particle of mass m is hanging vertically with an ideal spring of force constant k, it is allowed to oscillate vertically the total energy the options: A, maximum at the extreme position, maximum at the extreme position, maximum at the extreme position, maximum at the mean position, maximum at the mean position, C, minimum at the mean position, same at all the position, So here the question is: a particle of mass m is hanging vertically with an ideal spring of a force constant k. It is allowed to oscillate. So here there is a one spring, and this spring is connected vertically, and the load is applied to the spring. When we apply the force, the spring is oscillate up and down. So here, when the spring is oscillate up and down, that time we know that the energy changes. We know that at a height, due to the position, the potential energy is possessed, and due to the velocity, the kinetic energy is possessed. When the spring is at the highest position, means the highest position is known as the extreme position. When the spring is at extreme position, the total energy is in the form of a potential energy. And when the spring is down, or when the spring is mean position, means the height is 0 and the total energy is converted in the form of a kinetic energy. And at the middle, the total energy is in the form of a kinetic energy plus a potential energy. So here, at the height, the maximum position or at the maximum height, total energy is in the form of a potential energy and the kinetic energy is 0. Kinetic energy is 0, but the total energy is in the form of a potential energy. And at the mean position, total energy is in the form of kinetic energy and the potential energy is 0. So here the total energy, and this is also a total energy, means the potential energy and the kinetic energy, this ratio is changes, but the total energy is remains same. The total energy is at the highest position and the total energy is at the lowest position is remains the same. So see the option maximum at the extreme position or maximum at the mean position, minimum at the mean position or same at all the position. So here the question is related for the total energy and the question is not related for the separate kinetic energy and potential energy. So the total energy is remains the same at the extreme position means maximum position as well as the lowest position. यहाँ total energy हाइट के ऊपर और मैक्सिमम हाइट के पास भी सेम रहता, लोएस्ट हाइट के ऊपर भी सेम रहता. So in this type the option is a D. See the next question. A simple harmonic oscillator. Second question. A simple harmonic oscillator. A simple harmonic oscillator has a period 0.1 second, 0.1 second and amplitude amplitude 0.2 meter, 0.2 meter. The maximum velocity is given by. So here the options are given. The option A 100 meter per second, 100 meter per second. Option B is given 100 pi meter per second. Option C is given 4 pi meter per second and D option is given 20 pi meter per second. So here a simple harmonic motion or a simple harmonic oscillator means a body which executes a simple harmonic motion has a period. Means in this question the time period is given t is equal to 0.1 second and the amplitude means that is a is equal to 0.2 meter. What is the maximum velocity? So v is equal to what is the maximum velocity? So v is equal to what is the related formula for the v? We know that v is equal to r into omega. So v is equal to r into omega and at the maximum position this r is nearly equal to the amplitude at the omega. So amplitude is a given. Amplitude is equal to 0.2 but here omega is not given directly. Then substitute the value of omega. Omega is equal to 2 pi divided by t. Therefore omega is equal to 2 into pi divided by t. What is the time period given here? Time period is given as a 0.1. So the answer is 0.1 into 2 pi divided by 4 pi. That is the here. The answer is in the form of a 0.1 meter. Omega is equal to 2 pi by t. That is a 2 into pi divided by 0.1. So this is equal to the answer is a 4 into this is a 2 into pi divided by t. T is equal to 0.1. So this value is equal to 2 pi. So this is equal to 0.2 into 2 pi is equal to the answer is 2 to the 4 pi. The unit is a meter per second. So check the answer. That is a 4 pi meter per second. So the option C is a correct. So here first to read that question carefully, then use the related formula and do the rough calculation. The next question. Total energy of the particle, total energy of the particle, total energy of the particle, executing simple harmonic motion, executing simple harmonic motion is proportional to, is a proportional to, is a proportional to A, displacement of the particle, displacement of the particle, displacement of the particle, B, frequency of the oscillation, frequency of the oscillation, of the oscillation, frequency of the oscillation, C, square of the amplitude, square of the amplitude, square of the amplitude, D, velocity, velocity at the mean position, mean position. The total energy of the particle. So we know that the total energy is in the form of a kinetic energy as well as in the form of a potential energy. So the total energy for the simple harmonic motion, we derive the expression and we know that formula, that total energy in the simple harmonic motion is equal to, total energy is equal to half into m into a square into omega square. So remember the formulas and compare the formula with this. So see the option. Total energy is directly proportional to mass, directly proportional to the square of amplitude, and directly proportional to the square of angular velocity. So see the option. Displacement, there is no displacement. Frequency, there is no frequency. Square of the amplitude. So this option is a correct. So कभी भी आप लोग ये solve करते वक्त formula check कर लेना that total energy is directly proportional to the amplitude. Total energy is directly proportional to the square of amplitude. So the option C is correct. See the next question. A pendulum suspended. A pendulum suspended to the ceiling of a train, to the ceiling of a train, ceiling of a train has a period T, has a period T, has a period T. When the train is at rest, when the train is at rest. If the train is accelerated, if the train is accelerated, if the train is accelerated uniformly, the period will be. So see the option. A, increase, B, decrease, C, remains the same, t becomes infinite, becomes infinite. So see the question. A pendulum is a suspended. Means here the time period of a pendulum. We know that the related formula for the pendulum or the time period for the pendulum is. आप लोगों को time period of pendulum मालूम है. That is a t is equal to pi into root of L divided by G. So this is a time period of a simple pendulum. We derive that expression and we know that the related formula for the time period of a simple pendulum. Then see the question. A pendulum is a suspended to the ceiling of a train. If period is at t, means when the train is at a rest. जब train rest में है, तब उसका time period कितना है t. Means at the gravity is a g. When the train is at a rest, its acceleration or the acceleration due to gravity is a g. When the gravity is a g, the time period is a t. Okay. The next point, when the train is at rest, if the train is accelerated uniformly the period. इसके बाद train move हो रहा है with the acceleration, not at a uniform velocity. When the uniform velocity is there, means the acceleration is 0. But the train is accelerated. Okay, means the acceleration is a. So that time, what is the acceleration? Acceleration or what is the time period? Time period is a increases or decreases. What happened here? So here, t is a directly proportional to 1 divided by root of g. Okay. Then next, this is the first point when the train is at rest. But second point, train is accelerated with a uniform acceleration a. Means t is a directly proportional to g plus a. Then what happened here? The value of a g is goes on increasing. Then time period is decreases. So both are inversely proportional to each other. When the g is decreases, time period is increases. And when the g is increases, the time period is decreases. So remember this formula. So what happened here? The time period is when the acceleration is increases because there is acceleration due to gravity g as well as the acceleration of a train is a, means the time period is goes on a decreasing. So the option is B is correct. See the next one. Fifth, a pendulum is first vibrated a pendulum is first vibrated on the surface of Earth, surface of Earth its period is t. We know that the period, the time required to one oscillation is known as a period. It is then taken to the surface of the moon, where the acceleration due to gravity, is 1/6 that of the Earth. Its period will be the options are A T by 6, B T by 3, C T divided by root 6, D root 6. Here the comparison in between the earth as well as the moon. We know that the acceleration due to gravity on the moon is less as compared to the earth. So here a pendulum is first vibrated on the surface of the earth. Its period is t. आप लोग ये pendulum first earth surface के ऊपर रखे. So that time उसका time period कितना है t है. So we know that the related formula or that is a t is equal to 2 pi into root of L divided by g. So here there is a there comparison in between the two questions. यहाँ आप लोग compare कर रहे हैं. कौन से values में compare कर रहे हैं? Just the time period of gravity. तो आप लोग एक ही value ले सकते हैं. That is a t is a directly proportional to 1 divided by root of g. 2 pi get cancelled. So there is no need to write the complete formula. So t is directly proportional to 1 by root g. So this is the value on the surface of the earth. Next, this pendulum is placed on the surface of a moon. तो ये pendulum आपका मून के ऊपर रख रहे हैं. तब वो ग्रेविटी कितना हो रहा है 1/6 दैट ऑफ ए अर्थ. मींस अर्थ के ऊपर कितना है ग्रेविटी g है. तो मून के ऊपर कितना होता है g divided by 6. So write down here 1 divided by root of a g divided by the earth is a 6. So compare the values. When we compare this value, we got this t is equal to root of 6 root g cancel. This is a t on the surface of it. This is the surface of the moon. So we got the value. The time period on the surface of the moon is equal to 1 divided by 1 by root 6. Means the answer is a root 6. G get cancelled and we got the time period on the surface of the moon is equal to root 6. So here time period on the surface of the earth is directly proportional to 1 divided by root of a g. Second, this pendulum is placed on the surface of a moon. आप ये pendulum moon के ऊपर रख रहे हैं, but gravity is reduced to the 6th. तो यहाँ time period of moon is directly proportional to 1 divided by root of g divided by 6. Compare, divide करिए उसको दोनों को. So when we divide this, the root g get cancelled and we got the answer. Time period of the moon is equal to root of 6. तो आपका आंसर कितना मिल रहा है root of 6. So which option is correct here? That is a D option is correct. Next one. A simple pendulum consisting of a ball of mass m tied to a string of length L. It is vibrated and has angular amplitude theta at its extreme position another similar ball is placed at rest is placed at rest. The momentum transfer, the momentum transfer, the momentum transfer to the stationary ball, stationary ball is the options are A 0, B m theta g divided by L, C m theta divided by root of 1 by g, D m theta divided by 2 pi into root of L divided by g. So say what is the momentum? The product of mass into velocity. And the momentum is changed when the two bodies are collide to each other. Here there are two bobs are there. One bob is at highest position and the second bob is oscillating. When the second bob is vibrating, so when the second, so here this second bob is at rest. Is at rest means what is its velocity? Velocity is equal to 0. What is its momentum? Momentum is equal to 0. So what happened here? When this bob is collided to this bob, so that time the momentum of this first bob is changed. The second bob is at rest, so there is no effect of the second bob on the first bob, or there is no momentum is a change of the first bob because the second bob, because the bob is at a rest. So which option is correct? The first option A is a 0. The first option A is a 0 because at the extreme position the velocity is a 0. At extreme velocity is a 0. Is a 0. Velocity is a 0. See the next one. A part executes simple harmonic motion with a period 6 seconds and amplitude 0.3 meter, 0.03 meter. It is maximum speed. It's a maximum speed. In centimeter per second. Is first option pi by 2. First option is pi by 2. Second option is a pi. Third option is a 2 pi. And D option is a 3 pi. A particle executes simple harmonic motion with a period 6 seconds. So ये क्वेश्चन में आप लोगों को पीरियड दिए हुए that is a t is equal to 6 seconds and the amplitude is a 0.3 meter, means that is equal to 0.003 centimeter. The given is a 0.3 meter. Convert in the form of centimeter, that is a 0.03 centimeter. This here A is given. Its maximum speed is. We know that maximum speed is equal to R into omega. So at maximum the R is equal to amplitude, that is A into omega. So here which values are given there? A is given that is a 0.03, and omega is a converted, that is a 2 into pi divided by t, where time period is given as a 6. So here the answer is, that value is a 6. 2 to get cancelled, and the value is a, convert this in the form of a meter. Convert this value 0.03. So when we convert this in the form of 100, so the answer is 2 pi. So this is a 0.03 meter. Convert in the form of a centimeter into 100 into 100. So 0.03 into 100. So here B maximum is equal to R omega at a maximum position. R is equal to A. What is A given here? 0.03 meter. So convert in the form of a centimeter into 100. So omega is equal to 2 pi by t, where the time period is given as a 6. So here 2 pi means 0.06. 6 is get cancelled, and 0.01 into 100 is equal to, the answer is 2 as it is. So the answer is 2 pi. A is a 0.03 into 2. 0.03 is equal to 0.06 divided by 6 into 100. So the answer is 0.01 into 100 is equal to 5. So the answer is B. See the next one. A particle executing executing simple harmonic motion with the length of its path as 8 centimeter at a what displacement from the mean position, half the energy is the kinetic and half is the potential. Half the kinetic energy and half is the potential energy. So the options are A at 2 centimeter, B at 2 centimeter, C at a root 2 centimeter, at a D 4 centimeter. So here kinetic, half of the kinetic energy is equal to half of the potential energy. That is, half of the potential energy is equal to half of the kinetic energy. Substitute of both the formulas for the kinetic energy as well as the potential energy. Half into m into omega square into a square minus y square is equal to half into m into omega square into a square. Omega square into y square. So this is the formula. half get cancelled, m get cancelled, omega square get cancelled, and a square minus y square is equal to y square. Therefore, a square is equal to 2y square. A square is equal to 2y square. Therefore, a is equal to, substitute the value. A is equal to, find out the value of a. A is equal to y square is equal to a square divided by 2. Therefore, y is equal to a divided by root of a2, and the value of a is given, that is a 4. That value is given as a 8 centimeter. At what displacement a particle is executing? Half of the means, that is a 4 divided by root of a2. So the answer is 2 into root of 2. The answer is 2 into root of the 2. So the option B is the correct. So thank you, students.